I'm Christopher Burnell. I'm a Bay Area motion designer. I joined the Houdini's user group in San Francisco after attending one of the events at Pixar. They had, I guess I wasn't even aware that it had been inactive for the amount of time, but a conversation with Han had actually been sort of the, planted the seed of, oh, I need to learn this Houdini thing, because Cinema 4D had bottlenecks that I saw that Houdini was going to be able to sort of bridge. And those Pixar talk was just very much in line with it. The way that each artist took the software and was able to sort of run it through and really have it work with their particular department or skill set, or just the explorations that were done was just really, really inspiring. So by the end of that event, I was just, I don't know Houdini, but I want to learn it, and I do enjoy events. So that was enough to get Deborah Isaac's interest in looping me into some conversations, which eventually led to being able to be a co-organizer and work to get Michael Fredrickson in to talk about his experience at Pixar as a Houdini TD. So I think the thing that's so interesting about Houdini is the skill that tends to develop based on how deep you're able to dive with the software. I joked with Amy that's 2 year, to kind of get to a good place with it. But that number isn't necessarily arbitrary. I mean, it took me it only took 6 months to get into Cinema 4D, but to feel confident, to get paid, for people to ask me to make changes and stuff. So I'm still very much on that journey with Houdini, but I think that's what's really inspiring is that each artist has a different approach, and the way that you bring your interests, it just unpacks a particular section of it. So actually with that, I'd love to introduce Han Xue, who is a product designer at Lyft. He's experienced with visual effects and animation, and the work that I'm sure he's been doing at Lyft. I think you get a sense of, it's very old reel at this point, but the talent that's there from a design standpoint, but also from just a technical execution is really, really interesting. And I just want to thank him again for coming in here and sort of piloting this new format for partly for stay at home, but something that some of the other Houdini user groups around the world, there's sort of a network of them where they'll do the presentation, put it online, and that way groups from all over the world can sort of take part and watch those, and everybody kind of gets a little piece of it. So with that, Han, if you want to start your official presentation.
All right. So hi, I'm Han. Like Chris said, I currently work at Lyft as a product designer. I'm working in our self-driving vehicle research division for the past 3 years. So previous to that, I was working at Framestore doing FX. And then previous to that, I also worked in motion design and installation design. Sorry, that's my dog, by the way. And then for the last 3 years, I haven't used Houdini in the traditional or the more general sense that people use Houdini. Nowadays, I use it sort of as a 3D calculator. We need to, and sometimes to sort through data. Okay, we collect a lot of LiDAR data, camera images, and we do a lot of transformations through Houdini. But before that, I've done a lot of design and VFX related work. I have a little reel that I cut. This is 3.5 years old, I think, at this point. But I'll just play it to get a sense of the kind of work that I used to do. All right. So when I guess Chris and Side Effects first approached me, I thought of this title, transformations, abstraction, multiplication, and then how to think like a chef. So I don't want to let Jeff down, but that how to think like a chef part, I thought of that because I read an article about on product design for design systems. And the title was how to use design systems and how to think like a chef. So there are essentially two parts to this title. One is the first three words, the transformation, abstraction, multiplication, and then the second part. So these two parts are things I feel in the last few years I've been thinking about. Again, I haven't really worked in the motion design and VFX industry for this time, but I sort of still keep track with what people are doing, looking at people's work. And I've been thinking a lot about how, at least when I was working in that industry, there was very little sort of thought behind what we did. When we went into reviews or dailies, the criteria was if things looked cool or not, right? And having transferred into doing product design, saying you are doing something because it looks good, that doesn't work. You can't do that in presentations or reviews. So there's a lot of like theories and thinking behind what we do in product design and how we present things. And I always thought if you inject a little bit of that thinking into the motion design or just generative design world, it would probably sort of elevate the work. So that's the kind of stuff I would think that I'm sort of thinking about. I've never able to sort of articulate it in a format in front of people. And I thought maybe this is like a good opportunity for me to do that, as well as share some ideas. And so the three words that I was thinking that sort of always come up when I'm thinking about this kind of stuff is the transformation, abstraction, and multiplication. And sort of examples of each, right, is transformation. This is essentially what we do day to day. We're just taking pieces of information, we're transforming it into another format, and we're just doing transformations until we get what we want. But there are different levels of transformation. So the most basic or general version of transformation is essentially like translation, rotation, and scaling, right? So I think with the most basic form of transformation, where you're just moving the position of vertices, of points, of edges, or faces, if you do it artfully enough, you can do incredibly artistic things, right? Like animation, that's all that is essentially. But you can sort of go to other levels with that and get more creative and come up with things that are more unexpected. So other examples is like you can do a spiral simulation and use that data to drive particles, right? And then you are sort of transferring velocity into new positions, and then you can get like more organic movements, right? Like we all know, we've all seen those sort of effects. And then obviously there's like loads of other examples. And the one that I want to show later in the example is how do you transform between spaces? Essentially, how do you say transform a model into a UV space, and then you can do things on the UV space and you can transfer back using Houdini really easily, and you can come up with things that would be really hard to map directly onto a model. So that's transformation. Things like abstraction, again, that's just how like computers are built, right? If you think about it, you have like different levels of abstraction. You go from like really low level languages like C, C++, you go to higher level languages, you can go into software like Houdini, and then you can carry that on level by level, right? And come up with really unexpected stuff as well. So one thing that I see all the time is when I was working in effects, there's a lot of things that you redo all the time. An example is like an infection system, right? Which is like used everywhere now. But if you sort of package that, instead of developing the same infection system every single time, if you just take some time, package that up, abstract it into just a node, which Houdini does like brilliantly, right? Expose all the parameters that you want. And then once you have that, you can free up your mental cycles to build up the next level of effects, right? Like once you have the infection, what do you do after you infected the whatever, right? The geometry, the particles. So here I'm just going to show an example of this essentially the cover that I made for the Houdini events. How you can sort of develop the effect on one single curve, see how that works, and then you can abstract that and then build ever more complex things. And then the third word, multiplication, that's like a really easy and just actionable, I guess, idea that you can apply to your designs, in that computers are incredibly good at doing repetitive stuff, and Houdini is a procedural program. So once you set something up that works for one element, you can just populate that as many times as you want, right? And through repetition, you can get complexity. It's a really cheap and essentially you're letting the computer do your work, right? The RAM is the limit in that case. And it can come up with like some really interesting things. And that's also, I'm going to show that in this scene setup. Just before I dive into the Houdini scene, does that sort of make sense, by the way? Stuff that I'm thinking about, but I've never really articulated.
I kind of have a question for you.
Yeah.
When you're talking about moving from a three-dimensional XYZ space into a UV space to do some sort of transformation and then moving back.
Yeah.
Have you ever also used this same idea for multi-dimensional space, like more than three, like four-dimensional, like creating your own, other axis as a dimension?
That's something that I've been wanting to try. That's a really good question. Have you tried something like that before?
Not yet.
Okay, so I was reading up on what was it, quaternions recently.
Right.
There was a really good video on quaternion on YouTube, and there was a really cool visualization that they built. And I was sort of building that visualization in Houdini just to try to understand how that works. I think there is something to be explored there for sure. Like what would a design in 4D representation, which we as humans cannot grasp visually, be represented if you flatten it out into 3D space? You might come up with something really cool. And so, yeah, so this example, so I was scouring the internet for like references, and I guess the references that I am most familiar with are pretty old. They're still from the time when like I'm really looking into this stuff, but I think they're still really good references to get the point across. And so these are 3 projects that I found that I think is relevant. So these 2 top ones are from a music video for this artist called Max Cooper. And the artist behind this is a guy called Maxime Corset, I think. And it's a really cool video. It's really worth checking out. But then this is the 2 effects in it that I did a setup to just show some of the concepts that we just mentioned. Also, if you look at this video, there's like a lot more scenes, shots in this. And if you really look closely, you realize it's all the same setup, but just with different sources and different simulation parameters. So that's, again, I think going back to the abstraction idea, once you have one setup working on one curve, you abstract that away. You don't think about it anymore. And then you think about, you free up your mental space to be like, how do I have different sources to come up with completely different designs? And then this one, it was one of my favorite things when I first saw it, still is. And it's a design for Xbox by Man vs. Machine. And this is where, I'll show you later, this is how you have a sphere, and then in order to map this kind of geometry, it seems kind of hard. But if you flatten it out into UV space, it's super straightforward. And then the last one is this little shot here by this company called Marshmallow Laser Feast on a piece called, I think, Time Distortion or something like that. And again, I'll have some setups to show you how the idea of transformation works. All right, so just gonna jump right in. So this is the curve example. You guys see, by the way, the circles?
Yes.
Yep. Even the very light gray grid.
Oh, perfect. Awesome. All right. So this is a setup. This is the final setup. And I'm going to include all the, I'm going to upload the sync files. I'm going to comment it a little bit and then upload the sync file so you can really dig into it. I don't like when people go node by node. I think you can do that at your own pace. Mm-hmm. And also just because everyone's from different backgrounds. So it's probably better to just be higher level. And so, yeah, so this is the final setup after sort of studying that reference. And then it all started, so this is where the final setup is. And it all started with this little guy here. For the people who have no experience with Houdini, maybe there's like the next couple minutes might be a bit hard, but let's still go through it with it. So this thing here, essentially we have just 3 curves, right? And then this, for the Houdini people who haven't had a lot of experience, this thing, a solver, is sort of like a simulation. So this right now, I'm focused on this node here. This is what you see. This is what this node outputs. It's only 3 circles. And then through this simulation node here, it does something to it, right? And this is something that is being done a lot, like over and over again. It's called, I think there's a OD force thread called differential curve or something like that, where they talk about this at length. And this is what sort of people in that thread were doing, right? It's like, and actually I think most people, they were just doing one source, which is, this is what you get, right? This is kind of a pattern, which is super intricate, super interesting. For the people who know Houdini a little bit more, what I did when I first saw the reference is I was just thinking, hey, maybe I can just write my own solver. There's like sort of 3 forces that is responsible for this effect. One force that sort of keeps all the particles at equal distance apart. And then a force that sort of holds the line so that it doesn't go too crazy, like it averages the point beside it. And then I just like integrate, so you add the velocity at every single step. And then if you reset, because it pushes out the curve, it becomes longer. If you resample every time, you would have the same distance of the points again. And then at the next frame, you'll get pushed out a little bit more, right? Mm. And so this is pure, just some, literally just like adding some positions and then adding some positions to new positions to get new positions. And then this is what you get, the basic effect. And then this is where the idea of abstraction comes in. Once you have this setup working, you can plug it in, you can change the source, right? Right now, earlier I was looking at what you generate with only one single source. If you put 3 different circles, right, you can come up with a different effect, right? And then same node, same exact effect. Again, with the idea of abstraction, I don't think about it anymore. I just think about, hey, I have a setup that can do this, have this effect. How do I change the design if I change the source of it, right? So here, source is 3 static circles. What if I generate a bunch of other little circles all over the place? What would that look like? And then if you run it again, same exact setup, this is sort of the effect that you get, right? So I think to me, it's a lot more interesting than when you had just one circle and having that thing go crazy. It looks almost different, right? At first glance, you might think, hey, like that's a different setup than what this guy is doing, but literally same. And then when I'm again going back and studying this setup here, if you look at it, there's like a lot more complexity, and it goes like there's different levels of sourcing, right? Like you see a curve with sort of different, I guess, childs inside, and then it's not just a single child. Sometimes there's multiple, and then within the child you generate sub childs, I guess. And then in order to do that, this sort of setup doesn't cut it anymore. I realized I was running into issues, and actually it's really evident in when you're testing it out in the single curve setup, where it's sort of vibrates. I don't know if it's visible in the video, but you see how it vibrates? Because I guess the solver is too simplistic, and in order to calculate the position, it sort of goes back and forth between the frames, right?
Could you change the iteration level to get rid of that, or would it just slow down?
Sorry?
Could you change the iteration level of your solver to do that, or would you hit a wall because of performance issue?
So it's not iteration. I was trying to do more iterations through the simulation, and I realized it wasn't because of that. I think it's just in how I calculated the positions.
Okay.
It just considers. I think it's just too simplistic in how it considers. Does the point cloud lookup? It doesn't care about what the point is. If the point is sort of on a different part of the surface, it just cares about. It just does like a radius lookup.
Right.
Okay. And then, but the other sort of idea was, and that's also mentioned in the forum on OD4s. People just used grains to do the separate part, right? And that's super efficient. Again, that's another sort of level of abstraction. Like I don't care about how you're calculating the distance between things. Just use grains, keep my stuff apart at the same radius, and then I can think about how to generate the little children and how to do the sourcing in terms of complexity, right? Right. And so this is where the third iteration came. And the third iteration, again, for the Houdini people who know a little bit, this is just a solver, right, with some point wrangles in it. This one is using grains. And the first version of the grains, again, super simple. I literally just use a grain. And then I load in, this is just some velocity volume to make it more interesting. You don't really need that. And then in the solver, I'm just taking in new curves and then resampling, right? And then what that does, when you have an interesting enough source, again, this is what the source looks like. Again, actually, this source is the same as this source. So you can see like, this is the solver with the SOP idea. This is the solver with grains, same source, very vastly different results. And this is what it looks like. I'm going to go. Right? A lot more interesting, a lot more stable. Like you don't see that issue of vibration because it's just grains that are literally colliding against each other. The issue is this, as you can see, if I really want, like this is by itself, I think it's actually really interesting. But the effect I had in mind was, again, the thing that the cover I generated for this event. I want to sort of have this little bands that are all within each other, non-overlapping. And the issue that you see here is that obviously it doesn't understand that the curves need to be inside each other, so they overlap. Again, actually super interesting, I think. It's just not what I wanted. But yeah, so like it works now transferring from a solver solution to a grain solution. And we're already getting closer to what I had in mind. And then, again, abstracting that away. Just give me a second. I'm trying to simulate a lot of frames here. I don't actually remember what this was doing. Oh, let me see. So this one, I think that's it. No, that's not it. What was this doing? Oh, okay, yeah. So what this was doing is the source to solve the issue of stuff overlapping. I realized when I source, I actually need to understand where the previous source were. And what I did essentially is it added a little bit of complexity in how the thing is sourced, but it's still the same. These two are actually the same setup, right? It's just when I source the particles, I move not the particles, but the lines. I make sure that I always make them smaller so they don't overlap when they get injected into the simulation. And then I also sort of, as I know that the previous parent is moving, I sort of move the source as well so that it always goes into the circles, right? Does that sort of make sense?
Yeah.
And then what happens here is all the circles are inside each other, right? So this is sort of closer to what I had in mind for the effect that I wanted. Interesting enough, I think if you compare this to the previous that I originally considered to be a bug, when things overlap, I feel like it's actually more interesting, it's more organic versus this newer version that solved that overlap issue. But the way this works is, I think, sort of a hack in that if I don't move the source, I'm trying to sort of guess where the simulation would go, right? With how I source things. Which, again, is just a little bit of a hack. And because it's a simple solution where all the complexity happens in how I sourced it, the actual simulation itself is still relatively simple, right? It's the same setup as the one here with the bug. I'm just using grains and I'm just adding the circles. There's no complexity inside the solver here. And then the final idea is, hey, what if, and this sort of took the most time, and there was an interesting bug also, not bug, but like the way you set up grains, I guess. The idea is, hey, if I really want to abstract this and make it as robust as possible, instead of sourcing in curves, like this, maybe everything should just be points. And then all the calculations should actually happen inside the solver itself. And then this is the final setup, and that's what happens. Everything is just, you can't even see it because it's points. But you see like little points popping up. I don't know if you can see that. But so the final way is all the previous setups sources curves into the pop solver. This one sources points, and then inside the pop solver, that actually it actually generates the curves inside there. And again, I'm going to include the file. I think there are some clever things that was done here. And the interesting part is, like, in order for that to work, you can't plug in, the POP solver needs to be plugged directly into the SOP solver. If you plug it into any other stream, it doesn't work. And this is the final effect, which solves, again, the overlap issue, and then everything happens as a point. So actually, maybe this would be more clear. What happens is you see every single, the circles, not the spheres, are the source points, right? And what happens is as they generate, you see, boom, this one becomes a circle. So you'll never have overlap, right? Because this is also a grain, and this grain takes care of collision before the string is being sourced, right? And then there's two other particles that also converts into string later on. So this again allows us to do the multiple children within one circle, again, without having any overlap issues. And then, yeah, so this is the final version, and I think it's kind of interesting, right?
Mm.
For that, right? And I'm going to include the thing here because I think, so again, this, if you remember the previous setups, right? The SOP solver is just two nodes inside because it already takes the curves from outside. But here, there's a bunch of logic to generate the curves properly. So there's actually a lot more stuff happening now in the SOP solver. And I think there's some interesting things here. So it's maybe worth diving into it if you have the file. And so, yeah, so this is what the final thing. And then again, the idea of transformation, right, is like once you have this, yeah, it looks like all the other things. It essentially looks kind of identical to the reference, but how do you make this more interesting? And this is sort of like a really quick example, right? It's like, hey, you can generate different colors, you can generate different shapes, because there's loads of attributes that are generated with this simulation as well. Like I know exactly which iteration this is, so you can see the gradient, right? As you get closer inside, it's brighter. It's because I have like a value that generates this second iteration, third iteration. So I can use all of that and then do a bunch of different transformations to come up with things that looks a little bit different, right? And so yeah, that's that example. So I think that sort of shows the idea of abstracting things, so you can free up, again, your mental cycles to develop your setup further. I think the importance of sourcing is pretty evident, right? I remember I was talking to a buddy of mine who does like a lot of explosions back at Framestore, and he was saying how for him, he pretty much doesn't really change the solver that much, but it's all in his sourcing, right? So moving on, we talked mostly about abstraction and a little bit about transformation. The next one is, I think, something that was, once I realized, was super actionable when I was working. Sometimes when I'm stuck doing something, I'm like, hey, this doesn't look interesting anymore. What can I do? And then always the idea of just, hey, I can just take this thing. I don't need, maybe I can transform the particle movement into something else, right? And then you'll look different. So again, in the beginning, I talked about how you can different type of transformation. You can just have position strictly. But then I want to specifically talk about how you can transform between spaces. So I'll show you this first. So this is an example where, now the points are going to be too large. You can still see the points, right, in the screen. So we have a grid of points, right? Nothing special, just a grid. What we can do is you can transform this into polar space. Already super interesting, right? Like two lines of code. If you just transform your I guess in this case z and x coordinates into polar coordinates, and then what you can do with this though is super interesting, which I have an example later on. And then to see the transformation live, to see one-to-one what happens, you have the grid of points. It goes into polar space, right? Boom. And what's cool is, if you think about this, now I have things going radially or parallel, right? So if I run, say, a noise through it, that the noise that, say, goes up, I run the noise in this space, but then I transform my model into the normal space again. And what the noise would then look like is it's going to radiate out from the middle, right? So I'll show you that, what that looks like in a bit. Another example is you have a model of a sphere right here, right? And then we can transform the sphere into UV space. So if you, so if we do a, again, lens shape, you can see very simply sphere, flat, right? 3D shapes, pretty hard to manipulate. You don't know, I mean, like, you know where things are, but if something's flat, it's way easier to do add more complexity, right? You can do something with a flat shape and then just transfer that into the 3D shape. So there's a lot of like little tricks like this that I've encountered that I always like. There's a lot of things that is too abstract to be actionable, but things like this, examples are like I did a bit of hard surface modeling, and a lot of times you look at somebody's model and the details are really incredible on the model, and you would have people ask, hey, like, how do you get those details on? Like, I don't have, like, my mesh I can't have that kind of detail on the mesh. But then you realize if you like, it's super actionable, just like take your model, subdivide it once, and then most of the time you just don't have enough geometry to make the shape, right? So those kind of tricks I love, because it's not theory, it's just you just do it, and then you immediately improve the quality of your work, right? Another example is from like this guy G-Monk, who does graphic design mostly, and his trick was, if you wanted, he does some like future UI stuff, and one of the things that really stuck with me is that he says, hey, why is my stuff so much more detailed versus other people's work? And he says, what I do is, when the client tells me, hey, the final screen is going to be, say, like an HD screen, what I do is, in my software, which like he uses Illustrator, he's like, in Illustrator, I create a canvas that's 4K. So I create a canvas that's 4 times larger than the final design is intended to be viewed. I design in the 4K version, make sure that things looks detailed in the 4K, and then when you scale it down, it's just so much more complex, right? So again, super actionable. You just, when you start working, you just create things that's larger. So this again is something that's sort of actionable, right? Like when you're, again, transforming spaces, I've seen things like a ring, for example, like a sci-fi, I don't know, space ring that has a lot of details on it. But if you can, a lot of time you just flatten that thing out to a grid that's completely flat. You can add as much detail as you want on it, and you can just bend it, and then it's on a ring, and it looks sort of more complex than it actually is. So same idea here, right? We have the sphere flattened into a UV grid. Then you can do loads of different things to it. One of them, so here's the example. I have a line, right? I animate it. So actually, that's not the one I want. I have a line. I animate it across the UV space. So if you template the UV space, this is what happens across, right? What happens here is, once I have the line here, I can take my UV space, I ray it on top, so I understand where the line is throughout the animation. And one of my favorite Vex functions in Houdini, just prim UV, right? When you ray the curve onto the geometry, it generates this value, hit prim and hit prim UV here. You can use it. It's literally just one line. And what happens is you can transfer this position into your other position, right? And what that looks like is this, right? You have a circle, boom, goes like that. Here is probably a better example, right? This sphere is this plane. There it's literally 1-to-1, right? It's just we're no longer in 3D space, we're in a 2D space. And then if I run a line across, the line goes across. Why is that interesting? Not that interesting. I can generate this line with just a plane that slices through the sphere, right? But what if I do something a little bit different, where instead of animating a line across, right, I animate something just a little bit more complex, like a shape like this, right? Just 4 little curves, essentially. What would that look like? That would look like this. Boom, right? Xbox logo, right there. And then, I mean, this is a really hack way to animate, by the way. But I just do a time delay, and then you can just have a bunch of them, right? So in order to sort of have this shape, I mean, I don't know how they did it. I think probably something similar. But in order to have this shape, it's kind of hard if you want to generate this straight up onto the sphere, right? But if you transform it, much easier, right? And then the other example is the marshmallow laser feast example, right? Where you have this is actually like a scientific simulation or a scientific phenomenon where you have two, I think, black holes revolving around each other. It generates a gravitational wave that's like similar to this pattern. Essentially, like there's like a wave that generates, right, like that. And then you can render it. You can render it out with some cool shaders, and you get something like this, right? Which is kind of cool looking. So the thing used here is, if you look at the reference, there's like this noise that's running on top of the surface that's sort of radiating out from the center. That looks really cool. And how do you generate something like that, right? Because you have radio and all the noises are like flat, essentially. So what you can do is you have your little circle, you generate some stuff on it. You can essentially blend it back to a polar coordinate, right? Like you use a polar coordinate as your XY coordinate, and then again blend shape. That's what's essentially happening, right? And then because it's flat now, what's cool is I have noises, right? Noise that runs like this, down in a straight line, looks like this. Looks like this when it's transferred back to a radial pattern, right? So super simple. You already, like, no simulation or anything needed, right? This is the top view. You sort of generate like this. I don't know if it's really clear, but like you generate this sort of wave pattern super quickly that radiates out. Boom, like that. So again, this is just to show a lot of things. Times you wonder, hey, like, how is that shape being generated? Well, if you can flatten your original shape or a base shape to something else, a lot more easy to manipulate. You can add complexity when you add it back to your shape, right? And then once you add the two little black holes and then instance some points, render it out, and you get something cool looking. Yeah.
So is polar, when you say polar coordinate, is that the same as a UV coordinate system, or I mean, is that the reverse of a UV coordinate system, or is that a different coordinate system?
So polar coordinates is you have two You have two variables. You
Right.
have the angle, and then you have the radius, right? And
okay.
with angle and radius, you can define any
Right.
point on a 2D surface.
Right. So it's a different space transfer from going to a grid, from a two-dimensional grid to a UV wrapped system.
Yeah. So this is essentially what it does, right? Like you have a 2D x, y, and then you can use essentially this axis is the radius from the center, and
Right.
this axis is the angle.
Right.
Radius. So yeah, I mean that's pretty much as far as I prepared. So the thinking, again, to answer Jeff, unfortunately the thinking of the chef part was an article that I was reading, which is also something that I'm thinking about, but I don't know, maybe it's like worth discussing in the group. But the idea for me at least was that if I look at things now, it seems it's a lot more repetitive than when I first got into this industry. I feel there was a lot of more like really exciting things coming out, say 5 years ago, 6 years ago. Whereas now it just seems like just the remix of the same thing, right? And then in the article that I was reading on design systems is that they were saying essentially it's also linked to abstraction a little bit. Essentially, you have all these components or attributes in design systems. It's like typography, elevation, color, iconography, all these basic things that designers are just reusing. Like it doesn't make sense to reinvent color systems, or it doesn't make sense to reinvent iconography or typography. But if you use them in a masterful way, you can come up with things that are like fresh, right? And they're saying most people in the product design world are cooks, right? You have salt, you have salt, pepper, you have all the basic ingredients. You mix them up, you follow a recipe, and you can come up with something really delicious, but not original. And then you have a very small subset of people in this world who are considered chefs, right? And they use the same ingredients as the cooks in the kitchen, but then they come up with something that's drastically different. And then the question how to think as a chef, unfortunately, I don't know, because otherwise I would be a chef. But the idea is that, hey, maybe we should think about how to reuse the same elements, right? Like Houdini is a perfect example of that. You have all these incredible things that are abstracted away for you, like making simulations, pyro simulations, and everything. It's so much simpler today. But how can you use that in like more creative ways to generate things that are fresh?
Okay. Thanks everybody for coming out.
Have a good one, guys.
Thank you.
Bye.
Bye-bye.
Bye.